Welcome again to Wickerson Studios. My name is Michael Wickerson. It is Christmas Eve, and I've got to get to bed, and looking forward to tomorrow. But here's a nice example of what I can do and what I've been playing with. And 90% of this is after looking at Rajaa Issa's C# essentials for programming. And I pulled out this wonderful script called the Collatz Conjecture, and I just cut and pasted it because what would you do with it? It's pretty amazing. It's a script that says take any integer above 0. If it's even, cut it in half. Get that number. If it's odd, triple it and add 1. And keep doing that until it reduces itself to 1. So the script takes a while to run, but what I've done is use that data to take off all these things. Stop the turntable and all that. I've got this little geometry that's formed here, and even though it's kind of funky, it's not where I was going, but it produces pretty interesting form, and I really like it. Actually like it a lot. So there's elements of it I really like to keep, even though it's got its kind of lines kind of curving through itself. You'd have to fix it and cap it and do some work in Rhino. But I like that form's been generated and sculpted that way. Let me show you it. Let's take that over to visibility like I always do and off. And here's the ghosted form that exists in there. You can see what happens when I start to change this. It's pretty amazing as you move through, and I'll show you how I built the geometry. Keep in mind that that's actually a piece of geometry that's actually closed. Nice area. Everything tends towards 1, and of course the lofting of it you can break down, and you can kind of control these numbers and get it really organized. But the script itself is pretty much that. Couldn't be more simple. Let's just take a look at it. I did have to import, and I've had to do this for a little bit, some extra imports, which she does here, which you can get off of her online sources. But basically it's an integer x equals num, which I import. While x is greater than 1, you simply print x to string, because I want to see those numbers and I want to use them as data. And if the modulus is divided by 2, or modulus 2 is equal to 0, you know it's even, so then you can just cut it in half again, else it's you multiply it by 3 and add 1. And you keep doing that while it's greater than 1, and it will slowly work itself down to 1. So it's a really nice script to come to understand that, and hopefully you can wrap your head around it. Now what I did also is I went in and I wrote a grasshopper script. So let's take this one and make that one disabled, and let's enable this one, which is actually my grasshopper script, which I had a lot of fun with. So let's enable that, and you'll take a look at it. So what actually did I build? And this one doesn't have the Collatz Conjecture applied to it, but it's still a pretty cool geometry if you want to check it out. So what I've done is I've gone in, and we're just going to grab a little ungroup. I'm going to go in here, and I've grabbed a quad sphere, because I'm a sucker for a quad sphere. And there it is. After the quad sphere, I've grabbed the edges, the faces. And the faces, I've grabbed one single face. I've moved that face up. I've thrown it through a polar array in the Z direction. I've grabbed offset, grabbed normals and points by evaluating surface at 0.5 by 0.5 in UV directions. So that should be pretty simple. And I don't think I had to, since it was 1 unit, I probably should have reparameterized that surface. I don't think it matters, but I should do that. I then move those out on a vector by 10. You can bring that back in if you want. You don't have to make it so big. But I'll leave it at 10, and I could make that parametric tied to other numbers. The vectors are pretty easy. There's the vectors that are going to be moving them, so I just visualize those. This one I took off in case you just want to do one. You can just do that, but otherwise I can do them all if I bring them in. And then this is my surface from normal edit. Got to take all those points and move them off in that direction. I move them up, and this is This is really the surface. It kind of goes nuts off in this direction as I make a surface from points. That's when it really breaks down here. So I've got to get my data a little organized. Otherwise, I have my top surface and my bottom surface. And I'll show you how that works very smooth if you were just to have one item. So basically, you would come in, you'd have your surfaces on the top. You'd take your top surfaces and your bottom edges, and between those two, you would just loft between them. You get this really nice form. So you get those curves, and you get these curves, and then you just loft in between them and then merging them all together, you get this nice form. Now, of course, it does some crazy stuff in here if you're going to be using more than one surface. And I actually like that, and even though I've got to play with it afterwards, it's a really nice form that's generated. And I can go back in and decide the amplitude. I don't have to have so huge. I can shrink it down and get it more compact. but I think I'll leave it. And coming back to that initial length, it's kind of nice to play with. And then my data of my count is where it gets interesting. You can take it all the way down to 1. 2 is really basic, and you're kind of wrapping this around and kind of closing that off into a kind of bracelet. This last form is actually very nice without even the Collatz curvature, which doesn't stagger it out. So if I grab this one and I just pulled that into a bake, and there you go. Grab all those forms. You might want to group them into one object, and then throw that into analysis tool, surface analysis, and I kind of like that one as well. And there we go. Get a pretty nice form. We can leave our grasshopper now. You can see that it's got some really nice attributes. It's got some funky stuff happening up here. It's actually not building surfaces, so that's going to be, maybe modeled or taken as a test, but obviously it's not turning it into a 3D printed form. But there is some exciting areas that happen in here when you move it right up, and I really like this inner working surface play of what's happening here, even though some are surfaces not actually solid. So you could little show edges on that and check what this is, but I like that little form. Let's take that whole thing and hide it, and or we could just get rid of it, I guess, because I'm not going to use it. So I may go back into it and decide what I want to do with it. But that was the general form of what I was playing with. So I've gotten used to scripting a lot in Grasshopper, and that's pretty simple. So I just took that. Let's take the preview off, and then go back down to this one where the preview was with the Collatz curve. Let's enable, and there we go. We've got that one happening. And what's nice is you can throw a little stagger in here with the data that's coming out of the Collatz curve. Where did I use it twice? I think I brought it in. Actually, I only brought the data. No, I brought the data in here, and I thought, let's just take this one off. I'd found my list length, and I applied that to the count in the rotation. So the Collatz curve is going to change up quite a bit as you move through here. Let's take this all in and get this enabled. And so you can see the numbers of what's being generated, the list length of this. But as you start with different integers, and I've got it set from down to 0, which produces that first one, and 1 staggers it up, I think, a little more. So you got 0, 1, then 2 cuts, do some jazz, 3, and you can always take a look in here and see what you have. Now, sometimes, because of odds and even numbers, it generates a lot more numbers. But like I said, you've got some pretty cool forms that are generated here. I like 16, and once again, that's the one that I was using before, and I kind of like that. So bring that one back in. I wonder what happens if I go a little crazy. Or maybe really simple. Let's go down to something like that. And let's just analyze that and see that as a final form. I'm going to save this initial script because I like that. We'll just group that one. And we'll slide this one down. We'll say this is the Collatz curve right here. And I probably won't group it. But let's jump in here and take a little bake on Christmas Eve. There it is. Pretty simple design. You see how it folds through and kind of follows in this lofted, strange paper pattern. But once again, for renderings and for ideas and things, you don't always have to make things solid. You don't always have to take it in print. You don't have to turn the bronze and aluminum. But when you start playing with forms and building your own algorithms, I think that's a pretty cool thing. Thanks to Mr. Collatz and his conjecture that if you were to take an integer value and you were to if it was even, you were to divide it in half, anything above 1. And if it was odd, then you triple it and add 1. And then you look at it odd or even. Nice little script right there. And that's building these geometries, which I think is pretty cool. And nothing too fancy. And let's just take a little ghosted form in the back of the one I selected right here. And let's jazz it up so it's kind of wild. And there's a nice little, actually I like 16. Let's put 16 back on it. Yeah, there we go. And you can move that one out of your way if you want. I'm not sure where my my gumball tool went away. Let's just slide that back out of the way there and have this other one that I might want ghosted against it. So once again, I'll do a little analyze. So I'll do a curvature analysis this time on this one. There you go. You get some colors if you do that. At least I thought I would. Analysis, curvature, no, surface curvature analysis. There you go. You get your curve analysis of what's happening right there with some tight little bends and some creases in there. Anyway, I hope you enjoyed it. Have a Merry Christmas and have a Happy New Year, and I'll see you probably tomorrow, because what else am I going to do? I'll wake the kids up, get the presents open, have some good meals, and I wish you all the best luck into the new year. Take care.